Okay, so section 4.4 is on rational exponents and radicals, and we're going to review a property that you learned last year, and that would be that property when you multiply two power terms with the same base, then you can add the exponents. So for example, if you had x to the power of 2 times x to the power of 3, that would mean that you would have x times x times x times x times x. So basically that would be like saying x to the 2 plus 3, or x to the 5. So if we just use that power product rule, now to simplify these power terms, we'd have 2 squared times 2 cubed, that would be 2 to the 5, which would be 32. The next one would be x to the 3 plus 5, and again you can skip that step and just go to this step if you want, x to the 8th. Next one would be x to the 4 plus 2, or x to the 6. The next one would be t to the 3 plus 6, or t to the 9. And the last one, we can multiply the 5 and the 3 by each other and get 15. And then x squared times x cubed is x to the 5. Doesn't look like a 5. I'm just going to show the step for that too. So it'll be x squared plus x2 plus 3, and it'd be y to the 4 plus 2. So that would be simplified to 15x to the 5, y to the 6. Okay, so now if you take that rule, we can apply that rule to fractional exponents as well. So if we consider now, we're going to try to make a connection here between radicals and rational exponents. So if we look at the statement root 7 times root 7, we get root 49, which we know is 7. If we look at the expression 7 to the half times 7 to the half, using that rule of exponents we just learned or just reviewed, we get 7 to the half plus a half, which is also 7. So it seems as if root 7 times root 7 is exactly the same as 7 to the half times 7 to the half. So that appears to be a connection there, that 7 to the half is the same as the square root of 7. So now if we look at a cube root, and we look at cube root of 2 times cube root of 2 times cube root of 2, we know with our rules of radicals that we can combine that as the cube root of 2 times 2 times 2, which is the cube root of 8, and therefore 2. If we look at 2 to the 1/3 times 2 to the 1/3 times 2 to the 1/3, and use our rules of exponents, we know that that's 2 to the 1/3 plus 1/3 plus 1/3, which is also 2 to the 1, or 2. So 2 to the 1/3 appears to be the exact same thing as the cube root of 2. So if we take that and kind of generalize that rule, we come up with a rule for power terms with rational exponents. And if you have anything that is of the form base to a power of 1 over n, that's the same thing as the nth root of that base. And n would be a natural number, and x could be any real number. Now again, if n is an even number, we would have to have the radicand being a positive, or we would not be a defined answer in real numbers. All right, so you do have to remember though that if the denominator is 2, you don't normally write 2 as the index, you leave it out. So it's understood that when the denominator is 2 in your fractional exponent, that you basically are using a square root sign. And when the denominator is 3, then you'd have a cube root. All right, so let's just get some practice writing down or evaluating using fractional exponents first. So we've got the 25 to the half. You should know that that means now the square root of 25. And I know you can put this on your calculator using your to the power of button if you want to check on your calculator. But it would be nice to try to do these as much as possible by hand. That's your to the power of button, or it might look like this, or it might look like this. So you can check if you want using the calculator, but I would prefer you try to do as many as you can by without using the calculator, so that you get skilled at what these mean. All right, so the cubed 8 to the 1/3 means the cube root of 8 by our definition, and we should know that that's 2. And 9 to the half, using our definition, means the same thing as the square root of 9, which is 3. And the last one there, to the power of a third, would mean 64 to the power of a third means the cube root of, whoops, I keep hitting that button, sorry. Cube root of 64, which is 4. The next example asks you to express each power in radical form. So we're not actually going to evaluate these, we're just going to change them to radical form. So this 14 to the power of 1/3, by definition, means the cube root of 14. 0.35 to the power of a half, by definition, means the square root of 0.35. So you should know that when the denominator is a 2, that means square root. You don't have to put the 2 in as an index when you're doing square root. And 21 to the power of 1/5 means the same thing as the 5th root of 21. And 52 to the power of a quarter means the 4th root of 52. Okay, the next question asks you to express each radical as a power. So when you see square root, if you're changing that to power notation, that would be 12 to the power of a half instead of the square root of 12. And cube root of 28 would become 28 to the power of a third. The 5th root of 20 would be 20 to the power of 1/5. And the cube root of 76 would be 76 to the power of 1/3. In the next example, we're asked to use our skills now with changing to whatever form you want to evaluate and try to do these without using a calculator. So 64 to the 1/3 helps me to think that that's the cube root of 64, and that's 4. The next one with decimals, if you find decimals a little bit tricky, you can change the decimal to a fraction when they're asking you to do without a calculator, because they usually work out nice. So it's like 36.36 to the power of a half is the same thing as the square root of 0.36, which is decimal 6. But if you find decimals a little bit tricky, you can change the decimal to a fraction, right? Because 2 decimal places would mean square root over 100. So that would be the square root of 36 over 100, which is the square root of 36, which is 6, over the square root of 100, which is 10, or 0.6. Now, if you can go right to 0.6 right away, that's fine as well. So 32 to the 1/5 means the 5th root of 32, which is 2. And this would mean the cube root to the power of a third means the cube root of 8 over 125, which is the same thing as the cube root of 8 over the cube root of 125. And again, you can skip that step if you want and go right to 2 over 5. And the next examples, we have 0.25, which again, if you want to write it as a fraction, you can. But this means the square root of 0.25 or 25 over 100, which is going to be 5 over 10 if you write it as a fraction, or 0.5. And the next one would be the cube root of negative 1,000, and that would be negative 10. And the next one would be the 4th root of 16 over 81, which is the 4th root of 16 over the 4th root of 81, which would be 2 over 3. And the last one would be the cube root of negative 64. So that would equal negative 4. Okay, so another property is your power rule that basically says if you have a power term that's raised to a power, then you've got one base, 2 powers, you multiply the exponent. So for example, if you had x cubed all squared, that would be the same thing as x to the 3 times 2 or x to the 6. So we're going to use that power rule now to simplify each of these, and this would be 1 base 2 powers like that, so that would be 2 to the 6 if it's that pattern. This would be x to the 15, just multiply 3 times 5. This would be x to the 4 times 2 or 8. This would be t to the 18. 3 times 6 is 18. Now this one here is a little bit trickier, and it requires actually another property of exponents. You would have to realize that everything in here is being squared. So that would mean that the 5 was being squared, that the x cubed was being squared, and that the y to the 4 was being squared. When there's a product of terms inside, this is actually another property of exponents, that you can bring that power inside to each part if things inside the brackets are being multiplied by each other. It's called power of a product. So this would be 25 x to the 6 y to the 8th. So we're going to extend those rules now, like we did earlier, to fractional exponents. So when we take something, with the ones we've done earlier, we just had the numerator of 1 in the fraction, but now if we have something different than 1, you can kind of use this power rule that we just talked about and basically break down, for example, 8 to the 2/3. If you think of that as being 8 to the power of 2 times a third, and then kind of work backwards, and that would be the same as 8 squared to the power of a third. That would mean that you could work out the 64 and then raise that to the power of a third, and that would become the cube root of 64, or 4. Or we could have written 8 to the 2/3 as a third times 2, put the third first, and then use our power rule kind of working backwards, and written that as 8 to the 1/3 squared, and then done the cube root of 8 first, squared. So the cube root of 8 would be 2, and if we square that we get 4. Either way, we're getting the same answer. So this here is just showing you that you can kind of separate a fractional exponent into the numerator and denominator, kind of separate them as a product. So you could write it as 2 times a third or a third times 2, and then follow kind of order of operations to get your answer. So the first, if you look at the notes down here below, says the example demonstrates that the numerator of the exponent can be thought of as the power, while the denominator of the exponent represents the root. So you can see, and I remember when I think of that, I think of roots of plants. Roots of plants are in the bottom. So I know that the root, when I think of fractional exponents, I know that the root, the one that goes with the root, is the one that's in the bottom. So you can see up here 2/3, 3 was the one that went with the root part. You cube root either, which doesn't matter which way you do it, whether you do the squared first and then you cube root after, or you cube root first and then do the square, but it is a cube root that you're finding. So the number that's in the bottom of that fraction will always be the root. The order in which you perform the calculations doesn't matter, but typically it's easier, if you're doing mental math, it's easier to make it smaller first and then the larger part. So it's easier to root it first and then do whatever the numerator is after. Okay? So there are two definitions here for fractional exponents, and basically it says here that if you have x to the m over n, you can think of that as x to the nth root of x, basically, then raised to the power of m, or you can think of it as x to the m and then take the nth root of it. Either way, you're going to get the same answer. I think, though, that this way here is usually easier for mental math. Because you're rooting it first and making it a bit smaller. Oh, I hate my writing on this thing. Mental math. Okay, so this one here is usually a little bit easier for mental math because you're making it smaller first. Okay, so here are some examples now that we can do to help us get that pattern into our heads. So we've got 25 to the power of 3 over 2. So that whatever's in the bottom goes with the root sign. So I tend to do the root part first. So that would be the square root of 25 all cubed. So that would be 5 cubed, which would be 125. And again, b, the bottom, the one that's in the bottom goes with the root sign. So this would be the cube root of 8 all squared, which is 2 squared, or 4. And c would be whatever's in the bottom is your root, so that would be the square root of 9 all cubed. So that would equal 3 cubed, which is 27. And the next one would be the 4th root of 16 cubed, which would be 2 cubed, or 8. And again, we could have done it the other way, but it's a lot easier to root it first to make it smaller. For example, c there, if I were to do the top part first and cube the 9, I wouldn't be able to cube the 9 in my head as easily as I could square root the 9 first. All right, so the next questions are basically some practice questions for you to try. And the first one asks you to express each power in radical form. So we're not actually going to evaluate these, we're just going to put them in their radical form. So the first one is 4 to the 2/3, and remember that whatever's in the bottom goes with the root sign. So that would mean the cube root of 4 all squared. And I would accept that as an answer, or the other form you could cube root the 4 all squared. So you could square the 4 first and then cube root after. The second one, you could write that as the square root of 0.65 all cubed, which is the way we do it if we're doing mental math. Or you could write that as the square root of 0.65 cubed. So take the cube it first and then take the square root after. The next one would be the 4th root, whatever's in the bottom of your rational exponent goes with your root sign, of 32, all cubed, or take the 4th root of 32 all cubed. So either one of those I would accept as an answer. And the last one would be the 5th root of -4 all squared, or the 5th root of -4. And I would use brackets around that because -4 squared means -16, whereas -4, which is what we want, -4, the whole thing squared, that's +16. So they mean something different if you don't have the brackets around them. We want the -4, the whole thing, to be squared, so we should use brackets around it. Question number 2 asks you to express each radical as a power. So again, we're not evaluating, we're just changing it from one form to another. So if your base is 3 and the index is a 4, so that would go in your denominator, and the 3, the power 3, would be in the top of your fractional exponent. The next one, you would have 6 as your base, and then your exponent would be the fractional exponent with 5 in the denominator, because 5 is with the root sign. And then the power 3 would be in the numerator. And the next one would be 2, and it would be 3 over 5. Can't really read that. I'm going to try that again. 3 over 5. Top scale doesn't look like a 3. There you go. So 16 to the 5. Again, the one that's with the index is the one that goes in your denominator of your fraction. Question number 3 asks you to evaluate each of these without using a calculator. So the first one there, and again, when we're doing mental math, trying not to use our calculators, it is easier to do the root part first. So I'm going to square root the 16, then take my answer and cube that. So that would be 4 cubed, which would be 64. The next one, we take the fourth root of 81 and then cube our answer. That would be, the fourth root of 81 would be 3 cubed, which would be 27. And the next one, we have the fifth root, whatever's in the bottom. Remember, our fraction goes with it has the index of your root sign. And then it would be of 32, fifth root of 32. And then we want to take that answer and raise it to the power of 4. So that would be 2 to the power of 4, or 16. And the last one would be the square root of 4 over 9. And then we want to raise that to the power of 5. So that would be 2 over 3 to the power of 5, which would mean 2 multiplied by itself 5 times, which is going to be 32. And 3 multiplied by itself 5 times would be in the bottom, so that would be 243. The next one, it might be more helpful there to change that to a fraction instead of a decimal. So 0.008, I would write that in the equivalent form of 8 over 3 decimal places means 3 zeros in your denominator, so it'd be 8 over 1,000 to the power of 2/3, which would mean the cube root of 8 over 1,000, and then you'd want to raise that to the power of 2, which would be the cube root of 2, which is a cube root of 8, sorry, which is 2, and the cube root of 1,000, which is 10, all squared. Now you can reduce that if you want to 1/5 first before squaring it, but in any case you're going to get 1 over 25. If you didn't reduce it first, you would have gotten 4 over 100, which then reduces to 1 over 25. The next example, we're going to take the fourth root of 1 over 625, and then we're going to cube the answer. So the fourth root of 1 is 1, and the fourth root of 625 is 5. And then we're going to raise that to the power of 3. And then that's going to give us 1 times 1 times 1 is 1, 5 times 5 times 5 is 125. Next one is the square root, because the bottom in the fraction is a 2, so that's understood to be square root of 36 over 81. And then we're going to raise that to the power of 3. And that's going to give us 6 over 9. We take the square root of 36 and the square root of 81. And then we still have to raise that to the power of 3. And that's going to be 216, I believe, in the top. 6 times 6 times 6. 9 times 9 times 9 is 729. And if you, now that's instead not to use your calculator, but for that one there, I mean, it wouldn't be too hard to just multiply. 9 times 9 is 81, and then multiply that by 9. The next question is the cube root of negative 27. And then you raise that to the power of 4. So that would be negative 3 to the power of 4, which would be a positive 81. Okay, question number 4 asks, is there a difference between negative 27 in brackets to the power of 4 over 3 and negative 27 without brackets to the power of 4 over 3? So let's check. So if we take the first one, that would mean, or write down what it is first. So that would be negative 27 in brackets to the power of 4 over 3 equals the cube root of negative 27 all to the power of 4, which would be the cube root of negative 27 is negative 3, and raised that to the power of, that to the power of 4, you get 81. So if you check the negative of 27 to the 4 over 3, that would mean the negative of the cube root of 27 all to the power of 4, which would equal the negative of 3 to the power of 4. So order of operations says do your exponents first, so that would mean that we'd have to do the 3 to the power of 4 first, and that would give us negative 81. So there is a difference in the first one. And the second one, we've got the square root of -4 to the power, I should write out first which one I'm doing, so you'll know. So this would be, first one is -4 in brackets to the power of 3/2. And that would equal the square root of -4 all cubed, which is undefined because you can't find the square root of -4. So then if we try the next one, this would mean the negative of the square root of 4 all cubed, which would equal the negative of 2 to the power of 3. In order of operations, you do your exponents first, so that would be 2 to the 3 is 8, and you'd have the -8. So there is a difference in both of them. That negative in the brackets and outside the brackets does make a difference. Sometimes there will be ones where cube roots, it might not make a difference depending on what the number is in your numerator. For example, in the first one, if we had 5/3 there, for both of those, they'd both be negative. But because we have 4 there, when you raise a -3 to the even power, you'll get a positive number. So there was a difference. Okay, the next question talks about the area of a face cube is given by A equals V to the power of 2/3, where V represents the volume of the cube. If the volume is 64 centimeters cubed, determine the value of A. So A would be equal to 64 to the power of 2/3. So that would equal the cube root of 64 all squared. And that would equal 4 squared, or 16. And that would be your value for A. Okay, part B, biologists use the formula B equals 0.01 m to the 2/3 to estimate brain mass, B kilograms, of a mammal with a body mass of m kilograms. Estimate the brain mass of each animal. A moose with a body mass of 512. So in our formula, we've got B equals 0.01 m to the 2/3. So this time we have a body mass. So the body mass is represented with m. And that would mean that our equation would become 0.01512 to the power of 2/3. There's nothing here that says you have to do this without a calculator, so you could actually go 512, hit your to the power of button, bracket 2 divided by 3 bracket, and then multiply it by 0.01. But we're going to try to do this using mental math. So this would be the cube root of 512 all to the power of 2, which is going to equal 0.01, and that, sorry, I didn't mean to put equals there, 0.01, and that would be 8 squared. So that would be 64, and basically multiplying by 0.01 is like moving the decimal place, because it's like multiplying by 1/100, so you're moving the decimal place 2 places to the left if you're dividing by 100. So that would be 0.64 kilograms. Okay, so you could use your calculator if you want as well, and just put in 512 to the power button, hit bracket 2 divided by 3 bracket, and then multiply by 0.01, you should get the same answer. So the next question, we don't have a whole lot of room there, but we'll try to squeeze it in. This time you're looking for the brain mass for a cat with a body mass of 5 kilograms. So when you fill into the formula, you've got B equals 0.01 times 5 to the power 2/3. Now, there's no need of us changing that to, that looks like times 2/3. I'm just going to fix that. This should look, power should be raised a little higher than your base. So that one there, we know that we can't find the cube root of 5 easily in our heads and then square it. So we're actually going to have to use a calculator for this one. So this is going to be 0.01. We'll just do a step at a time. So you know, so this would be 5 to the power of bracket 2 divided by 3 bracket. And then putting the brackets around the exponent just prevents your calculator from taking 5 to the power 2 and then getting the answer and dividing it by 3. So you want to raise it to the full exponent of 2 over 3, not 5 to the power of 2 and get your answer and divide it by 3. You don't want that. That's why I put brackets around the exponent when you put it in your calculator. So when I do that, 5 to the power of bracket 2 divided by 3 bracket, I get 2.92 for around there, da da da. So if you, that's approximately, again, multiplying by 0.01 is the same as dividing by 100, so you're moving the decimal place 2 places to the left. So that would be 0.02924 kilograms, approximately. Okay, so there's some questions here on pages 227 to 228. Now try relate it to this section, and those are in your textbook.